Here are solutions to homework set number 2 for ECE 111 for spring 2025. Now in homework set number 2, we're looking at solving problems that you encounter when you take algebra using Matlab. Now algebra is all about solving one equation, one unknown. Well, using Matlab, I can do the same thing using numerical methods. In fact, I can solve problems that I can't solve in algebra using numerical methods. For example, the first problem is I've got a function y equals x plus 1 over x. Solve for x when y is 5 and when y is 10. Now in algebra you do different techniques. This is actually one that you can't solve by hand, but I can solve using numerical techniques. It helps to know the answer to find the answer. So what I'm going to do first is plot x versus y. So x is going to go from 0.01 to 15 in steps of 0.001. This is the transpose. I just happen to like column vectors more than row vectors. Doesn't really matter. Y then is x plus 1 over x. I've got to use that dot notation to tell Matlab don't do a matrix inverse, just do element by element inversion. Then plot x versus y. So this is what it looks like. Here's x, here's y. When y equals 5, I have two solutions. When y equals 10, I also have two solutions. So that's a graphical way to find it. And this homework set is find the solution using numerical techniques. So what I'm going to be doing is using Newton's method. With the Newton's method, you take a guess, like right here. If this is my guess, I'll draw the tangent. And where the intersects, that's my next guess. Keep iterating, and eventually it narrows in. To do that, I want to do two things. I want to first create a function in Matlab where I pass x, return the error, how far off my answer is, then use Newton's method to drive the error to 0. So here if I want to find out when is y equal to 5, here's a function. I'm going to guess x, calculate y, and return the difference between y and 5. Now what I can do in Matlab then, so here is my function called problem 1. In Matlab, CLC clears the screen, I can guess. Is x equal to 10? Here is 5.1. Is it equal to 6? You keep guessing over and over again until the error is 0. I could do it using guessing or let Matlab guess for you. This is using Newton's method. I'm going to make my initial guess equal to 2. And then guess, that's the answer, perturb it just a hair. Find the answer. Now draw the slope. What the slope does is, here's the sensitivity, change in y over change in x, actually inverted, change in x over change in y, times the error. One way to kind of see this is the y over y cancels, so the units are just x. I'm going to adjust x by x. That's one trick in engineering, get the units to match up, and usually that gives you the right equation. But anyway, this is coming back over here. I'm going to find the, subtracting 5. I'm going to take my guess, draw the tangent, see where that hits, that's my next guess. To see that in action, I can sit there and then run it. I'm going to run this for 10 iterations and see how it converges. My first guess was 2, second guess 5.3, and eventually winds up being 4.7913. That's one solution. If I make my initial guess close to the other solution, 0.1, it will iterate and find the solution close to 0.1. A second solution is 0.2087. So that's function equals 0. That's the solutions when y equals 5, two solutions. Change this to a 10. Save it. Now find where the solution equals 0. It's equal to 0, meaning y equals 10 when x is 0.1010. Or, let's find the solution close to 10. Again, it helps to know the answer to find the answer. The answer close to 10 is actually 9.8990. So there I just solved for y using numerical methods. First solution, second solution. Likewise at 10, first solution, second solution. And here all I just did format long just to show off. Gives you lots and lots of decimal places and kind of shows you that the error is driven to 0 pretty quick. Newton's method converges really fast. Problem 2. Here's another problem. I've got y is sine of 2x, y is 4 minus x squared. Find all the solutions using numerical methods. Again, one way to start is to plot it. I'm going to guess x goes from minus 4 to plus 4, steps of 0.01. Here's y1, here's y2. Plot them. Where the two intersect are my solutions. I can do that using numerical methods. What I'll do using numerical methods is create a new function called problem 3. I'm going to pass x, calculate y1, calculate y2, return the error. I'll then repeat using Newton's method. Only thing that really changes is I now want to find the solution that equals 0 for problem 3 rather than problem 1. Perturb it, reiterate 10 times. Make my initial guess minus 3. It iterates and finds the answer as being minus 1.85. If I make my initial guess plus 3, it iterates and finds the solution near there, 2.228. Problem 4 is, here's an equation. What this corresponds to is a light sensor. There is a thermal or photoresistor. As light level changes, the resistance changes. By measuring resistance, I know the light level. If I know the light level, I know the resistance. So given the light level, here's the resistance. How do you go backwards? Again, you could do that when you take Algebra 1, but here, using numerical methods, I can do the same thing. I'm going to find out if R is 500 ohms, what's the light level? I'm going to guess the light level, calculate the corresponding resistance, and return the difference between what it should be, 900 ohms, and what it actually was. Now if I guess the light level till the error is 0, I get the answer, or, once again using Newton's method, I want to iterate until the error is 0, now just using problem 4. And if I start at a guess of 10 lux, it iterates and says, actually the lux is 17.426593127426457. Lots and lots of decimal places. If I want to find 600 ohms, just change this to 600 right here. And to get 600 ohms, it should be 34.25 lux. Now notice the beauty of numerical methods. I can solve pretty much any problem. If I can get it into Matlab, I can find the function equals 0. It does help to know the initial guess. So it does help to kind of have an idea what the answer is, and it will very quickly converge to find the solution close to your guess. Finally, the last one is if I have a voltage divider. What this corresponds to is I have a 5-volt source. I've got a 500 ohm resistor. This is something we'll cover a little bit later. If you want to know where this problem comes from, this is where it is. I've got my light sensor. I'm going to measure this voltage. By measuring the voltage, I know the light level. The way that works is the light level changes the resistance. The voltage divider converts the resistance to voltage. I measure the voltage. If I measure 3.2 volts, what's the light level? Well, to calculate that using numerical methods, I'm going to guess the light level, calculate the resistance, calculate the voltage, then return the difference between the voltage and what I measured, 3.2. Now guess the light level, keep iterating until the error is 0, f of x equals 0. Now doing that, if I iterate 10 times using Newton's method, again everything stays the same. Newton's method is pretty generic, pretty universal. I will then iterate until the error is 0. At 3.2 volts, the light level is 17.79 lux. At 2.2 volts, 69.37 lux. So that's homework set number 2. This is looking at numerical methods to solve problems that you'll encounter when you take Algebra 1. The point of this homework set is getting used to using Matlab. Newton's method is really useful. It's used all the time. Conversion is very, very fast. There's other methods like California method, interval halving. My personal favorite is Newton's method. The other thing to note about this homework is Matlab is really powerful. I can solve pretty much any function using numerical methods, even functions I can't solve using algebra. I can solve using Newton's method. The trick, however, is it helps to know the answer to find the answer. So you got to kind of have a guess that's fairly close. Once you get fairly close, Newton's method will zoom in pretty quickly. It's pretty powerful. So that's homework set number 2 for ECE 111. Again, the point is getting used to using Matlab. We're going to be using Matlab extensively while you're at NDSU. You'll use it extensively when you graduate. It's a pretty powerful language. Homework set 2 for ECE 111.